Okay, so in example 1, we're just solving these equations. Be careful, it's kind of written sideways. I'm not sure why I set it up that way, but it is, so we're just going to deal with it. So remember on A, we know that if we can get like bases, then we can get rid of our bases. So can you take the bigger number, 32, down to the smaller number, base of 2? Yes, 32, remember, is 2 to the 5th. And then we know that once we get like bases, we can get rid of those, and it gives us our solution at x equals 5. Okay, on B, we have a natural log minus a natural log. Remember, we can combine those. We said because it's minus, how do we combine them? By division. So we really have the natural log of x over 3 equals 0. Well, when I want to rewrite this equation, remember natural log has a base of what? It has a base of e. So I'm going to write a little e there, even though we know it's not really written, it's implied. So then when I change it to exponential form, my a to the y equals x, I know that e to the 0 equals x over 3. Can I work that out? Yes. Well, we know that e to the 0, remember anything raised to the 0 exponent is equal to 1. So 1 is equal to x over 3. And then just solve for x. So we've got to get rid of the 3, so let's multiply it since it's being divided. And so 3 times 1 is 3 equals x. So our solution is x equals 3. And then on C, we have 1/3 to the x equals 9. Well, y'all don't like fractions, so let's get rid of it. Let's pull this 3 up to the top by changing the sign of its exponent. So 3 to the negative 1 to the x equals 9. And then you've got power to a power here. When you have two exponents, remember you multiply them. So 3 to the x equals 9. Well, just like letter A above, if we could get like bases, we can cancel out those bases. So can you take 9 to a base of 3? Yes. So we have 3 to the negative x equals, what is 9? 3 to the 2. Your bases are now equal, so get rid of them. So we know that negative x equals 2. Solve for x, and you find that x equals negative 2. All right, continuing on with example 1, letter D, e to the x equals 7. Now this one's a little different because can you get like bases? No. But remember, what you do to one side, you can do to the other to keep it equal, or you have to do it to the other to keep it equal. So on e to the x equals 7, if I had something that I could take and make this x here bungee over, then I could solve for x. Well, what is the one thing that that exponent can bungee back and forth across? A log. And since we have a base of e, we're going to use that special log, which is the natural log. So I have natural log of e to the x. Well, remember, as long as what you do to one side, you do to the other, we're okay. So the natural log of 7. Excuse me. And so that's really my rewritten equation here. So I have the natural log of e to the x equals the natural log of 7. And then we can work this on our way to our solution there. So remember, we can bungee that x in front of its log. So x times the natural log of e equals the natural log of 7. But remember, I told you, you can work this out, or you need to just remember, what is the natural log of e? The natural log of e is equal to 1, and when we take x times 1, we just end up with x. So we end up with our solution here, x equals the natural log of 7. So I'm just going to rewrite that over here. So x equals natural log of 7. What about on e? What can we do there? We have log equals a number. Well, let's go ahead and let's set it up as an exponential then. Natural log has a base of e. So when I set it up, I get my a, which is e to the negative 3 equals x. Can you do anything else with that? Well, it's a negative exponent, so we're going to do the opposite of what we did in C. We're going to bring it to the bottom. So we end up with our solution, x equals, because it's negative, it's 1 over, and then it becomes e to the positive 3. Moving on with F. Again, we've got log equals a number, so let's change it to exponential. Log is a common log, and what is its base? It's base 10. So when we set this up into exponential, we get 10 to the negative 1 equals x. Well, just like above, you don't like that negative exponent, or I don't either, so let's get rid of it, and we have to. So we get x equals the negative exponent. You send it to the bottom, and it becomes 1 over 10. And then finally on G, All right, on G, again, it's log equals a number, so let's set it up in exponential. So we end up with 3 to the 4 equals the x. And so we end up, you can work that out, and you get x equals 81.